Thank you for joining us for The Sky Above, where we will tell you everything happening in the sky this upcoming month so you can plan ahead and know when to look up. I'm Leah Pezzetti. Here's what is heading your way right now on this December episode. The new season is upon us. Winter is coming, and with that, the darkest day of the year. Plus, what is considered one of the most impressive meteor showers of the year is arriving when you have the best chance of seeing dozens and even sometimes more than 100 meteors per hour fly through the sky. And later on, our new guest this month is walking us through some of this year's biggest and brightest discoveries by the James Webb Space Telescope. We're discussing everything from the best view of the universe so far to capturing a dying star that transitions to a supernova. Those highlights from the year are coming up. Thank you so much for joining us. I'm your host, meteorologist Leah Pezzetti. I am joined, as always, by NASA Solar System Ambassador and member of the Seattle Astronomical Society, Keith Krumm. Keith, thank you for being with us once again.
Thank you, Leah. Great to be here again. Appreciate it.
We have a lot to unpack. So let's start, as we always do, with our full moon. December full moon. It's early this month, December 4th. So if you miss it, well, we have more to look forward to with supermoons. But we'll talk about that in a moment. Let's talk about this December full moon, go through the dates and the timing of that.
Great. It's a cold supermoon, it's called. So it's also the Mexican people. I really like their long night moon.
That's what they call it?
Yeah, they call it the long night moon.
Oh, and that's a good optimistic way of viewing it. We think short day, they think long night.
Long night. That's right.
Positivity right there.
That's it. Right.
So let's see, December 4th, and it's in the afternoon. So that means that kind of the days around it will at least appear full, 99%.
Yeah, it hits that peak at 3:14 exactly. So, and so if it's within 99%, then it's considered full. So it actually covers over 3 days.
Awesome. Oh, 3 days of a full moon. I love to hear it. And this is the third of 4 supermoons. This is something we've discussed the last couple of episodes, but of course we're right in the heart of these supermoons. We've said it before, let's remind people, October through January are our supermoons this year, the end of this year into next year. Right. What does that mean?
Well, it means that the moon is somewhere between 10 and 15% larger. It appears larger that way. I think that graphic says 7. This year, it could be as high as 14, and it's up to 30% brighter. So it gets very, very bright.
Amazing, because it's passing closer. It's not actually changing in size. It's the distance that we're seeing there.
It hits this great word perihelion, where it's the closest to Earth on that day, 222,000 miles.
Wow. And so this is the third. The fourth one will be the January full moon, is our final of this stretch. We see them in series. So if you miss this series, the next one, not until the end of 2026, November of 2026.
Yep. And it'll be a while before we have 4 in a row, but it's not unusual to have ones, like you just said, that are in a row like that.
Yeah. All right. So when your eyes look up and you see, oh, it's bigger and brighter, your eyes are not deceiving you. It is. Okay, let's get to winter solstice. It feels like winter has been here for weeks already, doesn't it? But technically, it doesn't start until the end of December.
Yeah, I mean, I love the fall.
Me too.
So, I mean, we were out yesterday, it was just beautiful. But, and we get these longer nights, right? So when it is clear, those of us who are out there doing astrophotography or something, we have more time. We don't have to stay up till 2 o'clock in the morning.
That is a good life lesson. We're going to continue with the positivity. For anyone who's saying, oh my goodness, our days are getting shorter, nights are longer, let's take advantage of that and get into astronomy.
Yeah. Right.
So there you go. Pick up some hobbies in the winter, and astronomy is a good one.
Exactly, yeah.
So we often think of it as the shortest day of the year, December 21st. Of course, that's alluding to the daylight. It's the least amount of daylight of the year. Let's remind everyone, in Seattle, sunrise is at 7:55 a.m. And we'll see sunset 4:20. So that's 8 hours and 25 minutes of daylight. That is the least amount of daylight we will see for the year. And then after that, of course, course, our days get longer. We get more daylight after that. So we'll start ticking up. Let's take it a step farther and talk about the why behind this. And I know you have a little prop that we also have here, but this has to do with the tilt of the Earth.
Earth on a stick.
Earth on a stick. Yeah. I like this. It's like a kebab.
Right now, we're over here on this side of the sun would be on the sun would be on this side.
You'll be the sun over there. Okay.
So the sun would be on this side. Excuse me. So it's the sun is low. The sun is pointed away from us.
Yeah, we're tilting the wrong direction.
We're tilted in the wrong way, right?
Yeah.
And so as we go through, and next summer, the sun will be pointed toward us. So.
Yeah, so you see that sunlight, we're tilted. So of course the southern equator is getting a little more daylight for us, and they're enjoying warmer summer conditions right now. Okay, so that's winter, that's the moon. Let's talk about some fun things flying through the sky. We are expecting one of the most impressive meteor showers of the year to grace the sky this year, this month. This is the Geminids. And this is going to be an impressive one. Let's talk about the timing of when people can look up and see this meteor shower.
Yeah, so really, it's so impressive that you can see it anywhere from the 1st of December till the 21st of December.
Wow.
So
all month.
All month, pretty close. The peak is the 13th.
Okay. And the peak
will be like up to 120.
Wow.
And the thing is, you say, well, which direction do you look for? Well, it's gonna be pretty much up at the zenith, right overhead. So it'll be slightly to the east, but it'll be radiating out of the constellation Gemini, which after 1 o'clock in the morning will be right overhead.
Okay. Okay. And I know we've seen videos and visuals of the Geminids in the past, and they are impressive. Yeah. They look like explosions in the sky. So definitely keep your eyes up in the month of December. And no, it's not a shooting star. That is a meteor. It's the Geminid meteor shower. So yeah, look at that. It's so cool to see them just flying through the sky. So December 13th, save the date for that. It'll be quite the show. Okay, but let's talk about the kind of big picture with these. It's part of a bigger show. These meteors look like they're coming from the constellation Geminid?
Gemini.
Gemini, which has twin stars, Jupiter. 4 moons are also visible as well. Yeah, so
Pollux and Castor are right next door. Those are the famous twins, Pollux and Castor, part of Gemini, the twins Gemini, so Pollux and Castor.
Okay.
And then right next door, right near there, will be Jupiter on that night.
Okay.
And with a good pair of sunglasses, good pair of binoculars, you can see the 4 moons.
Sweet. Okay. Yeah. So you'll look up and you'll get to see a lot of different things happening at the same time.
Jupiter has a lot more than 4 moons, but you can see the 4 Galilean moons, the 4 famous Galilean moons, with binoculars.
Okay. So now we all have to do is just hope for a clear night.
We'll find one.
We'll find a clear night. Let's talk about where the Geminids come from. It's a rock comet?
A rock comet, yeah. So we talk about comets generally as dirty snowballs.
Okay.
That have dust and a little bit of dirt on them or a little bit of rock or whatever. But those are the little tiny things that burn up in the atmosphere. A rock comet is actually an asteroid that behaves like a comet. It has a tail and it's dragging debris for some reason. Could be the fact that it probably had some kind of collision a billion years ago or something, and it's dragging these rocks with it. And that's the tail we go through of these meteors.
Interesting. Yeah. Oh, fascinating.
They become meteors. They're little pieces of asteroid. And when they hit Earth, they look like that.
Okay, so wait, hold it up for us. Hold it up for us.
Too small for here, but I have a bracelet with a little meteor on it, a little meteorite on it.
That's incredible. Here, hold it up for us. We'll get the tight shot. Brett will get it. There we go. Oh, there we go. It becomes
a meteorite when it hits the ground.
Oh, neat.
So that is an iron meteorite, and I tested it with a magnet, so there. And it has the right shape. So
cool.
Yeah, you said it was the nerdiest thing you've ever seen.
It might be, but you know what? I want one, so I'll join the club, join the nerd club. Okay, and this is not the only meteor shower in December. This one's not quite as impressive as the Geminids. The Geminids are known as kind of the creme de la creme, but this one could still produce a few meteors, so we'll keep our eyes up at the end of December.
Yep.
This is the Ursids.
Yep.
So let's talk about the timing of this one. This is December 22nd?
Yep, December 22nd. Again, this one is in a little different location, so this will be near the North Star.
Okay.
Near Polaris.
Okay.
It's in Ursa Minor. That's where it gets its name. And I'm going to look for it.
And look toward the Little Dipper?
Toward the Little Dipper, yeah. Ursa Minor, sorry, yeah.
Okay, yeah.
Little Dipper.
Go layman's terms here. Okay, all right, so we have a lot to look forward to. And then I just have to ask you, every single month we talk about red lights.
Yeah,
and
red
we talk
lights.
about when you are going to go stargazing, the Seattle Astronomical Society is always doing incredible events. You can join the nerds and they'll show you how to do it. You don't want to use your white lights because that ruins your vision. You want to use your red lights.
Right.
You have your hat.
Yep.
Did you bring another?
I did, because this, it's kind of the holiday season anyway, I guess.
Right.
So, but we use these all year round when we go out to star parties and so forth, because they really help you kind of find your way.
Mm-hmm.
I mean, you probably won't be able to see this in these lights, but you can set that down
Yeah,
at
pop it
your
right there.
seat.
There we go.
And just leave it there.
It is lit up, everyone.
And
It's just
it's
bright.
this wonderful shape, because down in Goldendale, when we first used them, we left them outside and it was 103 degrees.
Oops.
So they turned into this, looks like a meteorite.
It's unique, is what it is. I love it. You always bring a new way to see things with red light. Well, this got to be the fifth or sixth option I've seen.
These are very, very useful.
Very
Actually,
useful. I love
looks goofy, but they're very useful.
And then you can use it as holiday decor in the month of December. Okay. Keith, a lot to look forward to. I'm excited for the Geminids. I cannot wait to go out on December 13th. Of course, we'll hope for good weather that day. Yep. Thank you. All right. We'll see you back here next month with what's coming in January. Okay. But still ahead after the break, we're taking a look at some of the most impressive sights captured from the James Webb Space Telescope this year. These visuals are incredible. We're going to explain them all. Stay with us. Welcome back. The James Webb Space Telescope has been circulating the sun for about 4 years now, and every day that it's in space, incredible new discoveries are made. Professionals at the University of Washington are some that are closely monitoring those discoveries, and among them is astronomy professor Emily Levesque. Thank you so much for being with us today, Emily.
Thanks for inviting me.
I'm ecstatic to hear about all of the things that we're going to discuss. First, let's talk about yourself and what got you into astronomy and your expertise.
I've been interested in astronomy since I was a tiny kid. I was about 2 years old the last time Halley's Comet made a close pass to Earth, and got brought out by my family to the backyard, looked up, and after that people would ask what I wanted to be when I grew up, and I would say, well, I want to be a ballerina or an astronomer, or a firefighter or an astronomer, and astronomer just stuck. So today I work on really massive stars that are much more massive than our sun, and some of the really weird things that they can do and how they die. So how they make a supernova and leave behind something like a black hole.
Oh my goodness. And we are going to talk about a star dying and becoming a supernova. So we'll unpack that in a moment, but all of this goes back to the James Webb Space Telescope. So it's relatively new. The Hubble has been up for decades. This was launched, and we'll talk about the difference between the two later on, but let's first just do kind of a year in review. 2025. What did the James Webb Space Telescope bring discovery-wise? But first, let's tell people what this telescope is.
So James Webb got launched, like you said, about 4 years ago on Christmas Day of 2021. It's got a big primary mirror. It's just over 21 feet from end to end, so it's the biggest telescope we've ever put into space, and it's sitting almost 1 million miles from Earth. So it's at this stable gravitational point thanks to the Earth and Sun going around one another. And it's been constantly busy since we launched it. It's been observing for about the past 3.5 years, and it really does do groundbreaking new science pretty much every single day.
Oh my goodness. Okay, so we could sit here, I think, all day and just talk about what we've discovered so far. But let's go through the highlights, kind of rapid fire some of the biggest discoveries that came from the James Webb Space Telescope this year. You've chosen your top 5. Let's go down the list. We will begin with what is now currently the best and deepest view ever taken of the universe.
Yes.
Oh my goodness.
So we started with Hubble taking images called deep fields, where we would point the telescope to a seemingly empty patch of sky and just stare, because this is like with the camera taking a really long exposure. You just open the shutter and wait. So this new deep image from Webb stares at a tiny patch of sky. This would be like if you held a grain of sand about at arm's length, and it stared at that patch of sky for about 100 hours. So it was able to capture the very faintest and dimmest objects in the night sky.
Wow. Oh my goodness. And it's beautiful here right now.
If you pointed at that and just looked at it with a not quite as powerful telescope, it would look empty. But when Webb is able to put the full power of that enormous mirror on it and gather up all that light, you see this beautiful array of galaxies. You see tiny little faint smudges that are barely visible in that image. Those are actually the really groundbreaking objects that represent the farthest we've ever seen across the universe.
Wow, that's incredible. I can't even wrap my mind around that. Okay, and then another thing we talked about, stars dying.
Yes.
That's your expertise. We witnessed that.
Yes.
What happened there?
So an interesting thing about how stars die is that people may have heard of this idea of a supernova. So what will happen is a star much more massive than our sun runs out of fuel in its core. And that means that it can no longer run a little fusion reactor and sort of counteract its own gravity. That means the core collapses, the whole star tumbles after it, and you get this huge explosion that's incredibly bright. So we spot supernova explosions happening in distant galaxies, but one thing we're really not good at right now is predicting when a star is going to go supernova. We study the way these stars end their lives, we study the physics of how they work, but we're really bad at doing this on a human scale. We can say something like, oh, that star is going to die any day now, meaning in 10,000 years. So when we see a supernova, it kind of turns into a murder mystery. And what we do is we go back and look at the spot where the supernova happened, and then we look at observations from other telescopes in the hopes that maybe we happened to catch a glimpse of the star before it died. And this year we caught a Webb image of a star before it died for the very first time.
Wow.
Yeah.
So this is huge.
It's really exciting because the galaxy that we spotted it in is about 32 million light years away, and the star that we spotted we would never have seen without Webb, or we certainly would never have seen in such detail because it's enshrouded in this cloud of dust. Before stars die, they kind of undergo these violent shudders and puff off gas that cools off into dust, and that dust blocks our view, but Webb is designed to actually peer through that kind of dust and get a really gorgeous view of the star.
Oh my goodness, that's incredible. Wow, okay. And another highlight of the year, we got a great view of the Milky Way.
Yes, well, we got a great view of the center of the Milky Way, which is another thing that Webb is very specifically designed to observe. So Webb observes light that is redder than the light that we see with our eyes. And that light is particularly good at punching through thick gas and dust that would normally block our view. So this is an image of the center of our galaxy and a little piece of the center of our galaxy where brand new massive stars are being born. So you see this like beautiful array of stars, you see this glowing gas in the picture, but in the middle of it, it kind of looks like a normal-ish night sky, a lot more beautiful, but it kind of looks like a dark sky with stars shining through it. And what you're actually seeing in those dark patches are clouds of dust that are so thick that even Webb can't see through it. So you're actually looking at a bright star and gas-filled center of our galaxy, and then clouds blocking our way, so it looks dark.
Oh my goodness.
Yeah.
That is incredible to see. Oh my gosh. Okay, let's see. Another one, we've talked about this on The Sky Above before, but space dust. We got some new images of space dust. What is this?
So I feel like space dust sometimes gets a bad rap because you'll hear people say like, oh, why are we taking pictures of space dust? Space dust is fascinating. We're peering through it every time we try to take any observation of the night sky, and that dust comes from stars. It comes, in fact, from dying stars or interacting stars. So this is a gorgeous picture that got taken of 3 stars that are actually all orbiting one another. So there's 2 stars about 20 times as massive as our sun orbiting one another about once every 170 years. And they're on big, wide orbits, so when they pass near each other, they almost collide and they rip gas off of each other, and that gas turns into dust and makes a shell that starts sort of floating out from the orbiting stars. They've done this about 4 times in the past 700 years, so these shells that you see in that picture are dust drifting away from pretty much every time the stars fought. There's then a third star going around both of them and just sort of slicing a path through them. All of that dust is glowing at the exact color of light that Webb is designed to see. So we see this sort of luminous leftover of how these stars have been interacting for now hundreds of years.
Wow. Oh my goodness. Okay. Another thing that we've talked about, this is our final highlight of 2025, is exoplanets.
Yeah.
So these are planets outside of our solar system. We have 2 that we're keeping a close eye on.
Yes, so these are planets in the star system around a star called TRAPPIST-1. So TRAPPIST-1 is only 40 light years away. After what we've been talking about, this sounds like our backyard. But 40 light years away is still quite a distance, so we're doing everything we can to learn about the planets in this system. TRAPPIST-1 is this little tiny star. It's only about 10% the mass of our sun, but it's got 7 planets around it. And 3 of those planets lie in what we call the habitable zone, or the Goldilocks zone of the star. It's this sweet spot where the temperature on those planets should be just right to host liquid water.
Oh.
We think that liquid water is a key ingredient for life. This doesn't mean that the planets definitely have water or definitely have life, but it makes them really interesting to look at. And Webb, again, is perfectly designed for studying these stars' atmospheres because we can actually gather up the light from the star passing through what we think might be the atmosphere of the planet, spread out that light according to its color, and take what we call a spectrum. And this means we can measure the chemical fingerprint of everything that light is passing through. So we're looking at 2 of the planets in that star's habitable zone to see, is there an atmosphere there? Does that atmosphere have things like carbon dioxide or methane or water, the stuff you would see if you were looking at Earth from far away? And we're trying to get our first hints of what exactly is in that atmosphere and whether they are the sorts of planets that could potentially host life.
Oh my goodness. Okay, well, I'm ecstatic to keep an eye on that research. Okay, so those are the highlights from 2025, and there's so much more. And speaking of so much more, how does NASA decide where to look? You could go in any direction and zoom in, and goodness, how are those decisions made?
NASA actually puts out a call once a year to the entire astronomy community that basically says, submit a proposal, tell us what Webb should look at next. And Webb is a victim of its own success. The last time we did this, just about a month ago, we got 2,900 proposals submitted by the astronomy community.
Wow.
We dole out telescope time in hours, and people asked for more than 100,000 hours of time to point at everything from exoplanets to dying stars to black holes, everything you could possibly think of in the universe. And unfortunately, we only have about 8,000 hours to give out. When you think about it, it means we could build a dozen Webbs and still not run out of things to point it at.
Yikes.
Yeah, so what we have instead is we have volunteers, hundreds of volunteers from the astronomy community that read these proposals. They assess their scientific merit. They look at the balance of science that we're doing. And we put together over the course of a several month, really grueling process, the program for what Webb is going to be looking at for the next year.
Are you helping with this?
I am, yes.
Oh. That is exciting. Oh my goodness. Emily, we could sit here and talk all day, and I'm going to keep you here. We're going to bring Keith back in. We're going to keep talking about the James Webb Space Telescope and how does it compare to the Hubble. That conversation is next. Welcome back. We're going to continue our conversation about the James Webb Space Telescope, and I do want to bring Keith back into the conversation. I know you have a lot to talk about as well. You're excited about this, but so the Hubble has been in the space for 35 years. James Webb just 4. But how do the 2 compare?
Yeah, they complement each other really well because they observe different types of light. Hubble observes the kind of light we see with our eyes. It can see ultraviolet light, which is too blue for our eyes to see, and actually too blue to make it through our atmosphere for the most part. And then Webb observes light that's much redder, so they combine really wonderfully.
It looks like the camera is much clearer though as well.
Well, that's because the Webb mirror is much bigger. If you think about something like a telephoto lens that you see with a sports game, they're able to take really, really sharp images because the diameter of the lens or the diameter of the mirror is so big. So Webb is able to take these gorgeous detailed pictures because it's got that much bigger area for collecting light.
Interesting. Keith, what are your thoughts?
I'm always really interested in how these work together and support each other, as well as the huge ground-based telescopes. that are out there, and they all have to sing together, and share data in order to get this complete picture. So you can probably say a lot more about that.
Yeah, one difficulty with putting things into space is we're always limited by weight. So we've only been able to put a mirror about as big as Webb up, which is still astonishing, but we have even bigger telescopes on the ground that are 20, 25, 30 meters across. And those are able to take even sharper images, and they combine with Webb's advantage of being outside of Earth's atmosphere, able to take these beautiful pictures sort of unmarred by turbulence in the upper layers of the Earth's atmosphere, and it really just makes for a wonderful combination.
Oh my goodness, and so much more to discover.
Yeah.
We are out of time. Thank you both so much for your expertise. That does it for us here on this December episode of our monthly show, The Sky Above. We'll be back with you next month.